Hello friends, so this is the fourth question related to maximum power transfer theorem. So this is a circuit here, and we have been asked to find the value of RL for maximum power transfer to that load resistance and the value of that maximum power transfer. So first step is to find the Thevenin equivalent circuit across this load resistance by open circuiting it first. Okay, so let us redraw the circuit. 1 ampere, 300 ohm, 300 ohm, and then 600 ohm. So we have to find VTH. Now here, if you notice, we have a 1 ampere current source in parallel with this 300 ohm resistance. So here we can apply source transformation to convert it into a voltage source in series with this 300 ohm resistance. Okay, so what we can do is that we'll convert it into 300 into 1 ampere, that is 300 volt voltage source in series with this 300 ohm resistance. Okay, now please pay attention to the polarity of the voltage. Here the arrowhead is pointing downwards. That's why the polarity is first minus then plus, because current always flows from positive to negative. If the arrowhead would have been upwards, then the polarity of the voltage would have been like this, plus minus. Here the arrowhead is downwards, so that's why the polarity is opposite, minus then plus. Okay, so now we can simply apply the voltage division rule to find the voltage drop across the 600 ohm resistor. Okay, so here it would be VTH is equal to minus 300 into 600 by 300 plus 300 plus 600, because 300 and 300 they will be in series, so totally we can find it out. So it will be 300 600, which is 1200, and this is minus 150 volt. VTH is equal to minus 150 volt. Okay, we have got VTH. Now we have to find RTH. So in the same circuit, if we have to find RTH, then we have to deactivate the independent sources. So here we can short circuit this this voltage source, and we will get RTH as (300 plus 300), because they will be in series and the resultant will be in parallel with 600, that is 600 parallel 600, which is equal to 600 into 600 divided by 600 plus 600, that is 1200, that is equal to 300 ohm. RTH is equal to 300 ohm. VTH is equal to minus 150 volt, RTH is equal to 300 ohm. So the value of RL for which maximum power will be transferred to the load is RL will be equal to RTH will be equal to 300 ohm as per the statement of maximum power transfer theorem. And the maximum power that will be transferred to the load as per the statement of maximum power transfer theorem is VTH square by 4 RTH, which is equal to minus 150 square by 4 into 300 ohm. That is, let us calculate. Okay, 1 minus 150 square divided by 4, 300. Okay. So it is coming around 18.75, or we can write it as 18.8 watts, or 18.75 it is coming. We'll round it off, 75 watts, or nearly equal to 18.8 watt. Okay, so this is the maximum power that will be transferred to the load. So here all we did was to find the VTH and RTH. So we applied source transformation first, converted this whole current source into voltage source, then applied voltage division rule to find VTH is equal to minus 50 volt. Then we found RTH. Then, as per the statement of maximum power transfer theorem, for maximum power transfer the load resistance should be equal to the Thevenin resistance, which is equal to 300 ohm, and the maximum power transferred to the load is equal to VTH square by 4 RTH, which is equal to 18.75 watt, or nearly equal to 18.8 watt. Okay, so this is the fourth question related to maximum power transfer.